Hey everyone and welcome back. Today, we are diving deep into a React feature that, let's be honest, has probably made every single one of us scratch our heads at some point. We're talking about React Strict Mode.
You've probably been here before, right? You're staring at your console asking this exact question. You write a component, you pop in a use effect to grab some data, and bam, your network tab shows two identical requests. It just feels wrong, like it has to be a bug.
So your first instinct, naturally, is to hunt down that strict mode component in your app and just delete it. Problem solved, right? Well, what if I told you that strict mode isn't the problem at all? It's actually the detective, pointing its finger directly at where the real issues are hiding. Okay, let's get into this.
So let's completely reframe this conversation. Is this whole double rendering thing a bug that's breaking your app? Or is it a carefully designed feature that's meant to make your code way stronger? Let's uncover the truth.
First things first, what even is it? Well, React Strict Mode is basically a helper tool that you wrap around parts of your application. And here's the most important part. It only runs in development. It does absolutely nothing in your production build. Think of it like a pair of training wheels for your bike. They might make a bit of noise when you wobble, but they come right off before the big race.
And this is where we really flip the script. We think strict mode is causing bugs because, we see our effects run twice. But in reality, it's just shining a giant spotlight on bugs that were already lurking in the shadows. We think it slows things down, but no, zero production impact. So instead of disabling it, we should really learn to embrace it as a guide for writing cleaner and more future-proof code.
All right, let's get to the main event, that infamous double render. Why on earth does React do it? Well, there's actually a very clear method behind what looks like total madness.
Yup, this behavior is 100% intentional. It's a deliberate stress test that React is putting your components through. By making things run twice, it's checking for two very specific and very common types of bugs that can be a real pain to find otherwise.
And here are the two big culprits it's looking for. First, it's hunting for something called impure functions. These are sneaky functions that can cause unpredictable behavior, which is a big no-no in React. And second, it's making sure your use effect hooks have a proper cleanup plan, which is absolutely critical for preventing memory leaks and other weird bugs.
So let's quickly nail down what a pure function is. It's just a predictable function. You give it a 2 and a 2, it always gives you back a 4. Simple. It doesn't mess with anything outside of itself. React components are designed to work just like this. Rendering your component shouldn't suddenly change a variable somewhere else in your app. Strict mode helps enforce this by running things twice. If a function is pure, running it again changes nothing. If it's impure, well, that's when the bugs start to show up.
And this is how React stress tests your effects. In development, it mounts your component and runs your effect. But then it immediately pretends to unmount it, and it runs your cleanup function. After that, it remounts the component and runs the effect a second time. If your code breaks during this little dance, it means it would have also broken if a user, say, navigated to another page and then came back.
So now that we get the diagnosis that strict mode is just a tool telling us what's wrong, let's talk about the solution. The goal isn't to turn off the tool, it's to actually fix the problems it finds.
This right here, this is the mental shift we all need to make. We should stop Googling how to stop use effect running twice. The real question, the one that leads to much better code, is how do I write my effect so it can be mounted, unmounted, and remounted without causing any problems?
And these are the exact kinds of bugs this approach helps you squash. Things like accidentally making an API call right in the component body instead of inside an effect. Or, a classic one, setting up a subscription or a timer and then completely forgetting to tear it down in the cleanup function. These are the silent bugs that lead to memory leaks and really bizarre behavior in production.
Let's look at a super common example. On the left, a standard fetch call. If this component unmounts while that request is still flying through the internet, the code will still try to update the state of a component that doesn't exist anymore, and that's a bug. The fix is on the right. We use something called an abort controller. The cleanup function we return simply calls controller.abort. Now, if React unmounts this thing, the network request gets canceled. Bug squashed.
Embracing strict mode isn't just about fixing the bugs you have today. It's actually about getting your application ready for the future of React. And that's a really big deal.
See, the habits that strict mode forces you to adopt, like pure components and effects that clean up after themselves, they're actually prerequisites for really powerful new features like concurrent rendering. This is a future feature that will let React do amazing things to boost performance. So
By writing strict mode compliant code today, you're making sure your app is ready for tomorrow's React.
And let me just make this crystal clear one last time. This table lays it all out. All of these extra checks, the double renders, that whole mount-on-mount remount cycle, they only happen in development. Your final production build is fully optimized, everything runs once, and there is zero performance hit from strict mode. None.
So I'll just leave you with this question. Strict mode basically gives you a choice. Would you rather have it point out your mistakes while you're safe in your development environment, or would you prefer to let your users discover those bugs for you out in the wild? When you put it like that, the answer's pretty obvious, isn't it?